Hello there guys, this is Teacher Krishna and welcome to our first lesson for the third unit. This is a class that is part of the high school. The grade that we're going to be working on is 11th high school. And just like you noticed, this is the subject Physics 2. And of course, we are going to be working for week number 22. Remember to have your notebook with you in order to make today's summary. Something very important to notice is that we are not going to have any digital summaries anymore, but you need to have everything in order in your notebook. So we're going to be working on physical summaries this time. So make sure that you go for it. Remember that for the summary, you always need to include the date, the ending mind, the title, the summary, and of course some extra decoration for it. Remember that depending on what you're writing, it should include different color pattern. For example, the ending mind, the titles, and subtitles must be written down with blue and red. And the rest of the summary has to be written down with red and black. So make sure to take it into account as well. And when you have all of your materials ready, you can come back to the video so we can move on. Alright, so today we're going to be working on topic 6.06. The topic is Snell's Law. The ending mind for today is the following. Describe and apply the principles and theory of Snell's Law in applicable physics problems. Alright, let's move on. I'm going to give you a small summaries of the activities that you need to do. So first of all, you need to watch this video and make a summary, which is basically what you're doing right now. Number 2, you need to read topic 6.06 and complement your summary. I already included most of the information from the topic in this video, but it is always necessary to reinforce your reading skills. So make sure to go to topic 6.06, double check the topic, and of course complement what you already have in your notebook. Number 3, complete the application problems in page number 4 of topic 6.06. In this presentation, I'm going to give you some applicable problems, and of course we're going to put into practice a lot of theory and formulas that we are learning. But in page number 4, there are some exercises that you need to complete in your notebook in order to review a little bit all of the knowledge that you have already learned in the presentation, and of course to check your understanding. Then number 4, complete the manual or virtual lab simulation found in page number 5. This activity must be done in your notebook. So this time you don't have to submit the manual or virtual lab to Agilex, but you just have to make it in your notebook. At the end of the unit, I'm going to receive your notebooks, and there I'm going to be checking the lab that you have done. And of course, I'm going to assign you a grade at the end of the unit. Alright, so after the summary of activities that you need to do, let's go with our topic for today, which is Snell's Law. This is a small introduction and a little bit of a spoiler right now. There you have a picture of the way light rays are refracted in a different way depending on the medium they are at. So, to have a small introduction, please go to page 1 of topic 6.06 and complete the experimentation that you find there. You're going to find the steps to complete the experiment, and of course you're going to find some questions to reflect on the experiment that you are going to do. So make sure to go over it and remember to write down your results and your data in your notebook. Once you are done, you can come back to the video so we can continue talking about the Snell's Law. Alright, so welcome back. Now we are going to talk about the index of refraction. What is it? First of all, we need to analyze the definition of medium and the material in which light travels through. When talking about light, a medium is usually a transparent material such as glass, water, and air. We talked about waves in a previous topic, and remember that we learned that the waves usually travel through a certain medium. And we're going to focus specifically on light when talking about the Snell's Law. And of course, we're going to be analyzing water, air, and glass. We also have the optical density, and it is how easily light can travel through this material. The denser the material is, the slower light trespasses it. Light travels faster in air than in glass. And of course, light is going to travel faster in air than in water. And going back to the experimentation that you just did, we have a distortion on the image in which, right above the water, we're going to find like another image than the one that is underwater. And of course, it's somewhat weird, right? Because the pencil doesn't seem to match. But it's because of the optical density, is how easily like light is going to travel in each one of the materials. And of course, we have the index of refraction, which also relates to the optical density. The index of refraction is the value that is given to transparent material. The higher the value, the greater the diffraction of the light rays. And we're going to have a certain diffraction that is going to come from light when it travels in air, and right after when it travels in the water. That's why we can see the modification of the image of the pencil inside the glass of water. So in order to find the index of refraction, we have our formula right there. So we have then N equals C divided by B. N is going to represent the index of refraction. C is the speed of light in the vacuum. It has a constant of 3 exponent 8 meters per second. And of course, we're going to have letter V, which is going to be the speed of light in the medium. The unit must agree with C. It is very important for you to remember that like light is going to have a constant, which is the one that is already shown in there. So it is very important that you write it down in your notebook so you can keep track of it and apply it in the incoming problems that we have. And let me check. Oh yeah, and little observation. Even though it says exponent 8, remember that whenever we're working this connotation, remember that a 3-point exponent 8 will be 3 times 10 to the 8th power. It is very important to consider so you don't get confused when entering those values in your calculator, and of course you can manage to get the correct result. Right, so here we have our first application problem. So, light travels at a speed of 1.98 exponent 8 meters per second through a glass window. What is the index of refraction of the glass? So, first of all, just like always, you need to write down the givens of the problem. So, let's analyze what givens do we have. We have letter V, which is the speed of light in glass. So it will be 1.97 exponent 8 meters per second. And also we already have C, which is the constant of how fast light travels in the vacuum. So it will be 3 exponent 8 meters per second. Remember that the formula that I showed you in the previous part of this presentation was that the index of refraction, N, equals C divided by V. And right over here, we just substitute the information. Remember that when we have E8, for example, it will be 3 times 10 to the 8th power. So when you enter everything in your calculator, you will get the correct result. So what is the index of refraction of the glass? The index of refraction in the glass is 1.52. You might notice that it doesn't have any unit. Because, like, if you notice right here in the formula, there are meters per second at the top and meters per second at the bottom. So they both are just eliminated. So at the end, the value that we get as a result does not have any units, such as meters, seconds, etc. Alright, so let's continue. Here we have a table with different substances and, of course, their index of refraction. It is very important that you copy this table of content in your notebook. So one more time, when you encounter any problems related to the Snell's law, you can go back to this table and of course help yourself out with it. Like you notice, we have different substances such as air, water, ice, diamond, so on and so forth. So go ahead, copy it. Once you are done, we can continue with our presentation. Alright, so let's continue. Now let's talk a little bit more about the Snell's law. It was discovered by Wilbrord Snell in the 15th century. It is a formula that helps scientists predict the path that the light will follow when going through a medium. Right over here. So basically, this is what a diagram that represents the Snell's law would look like. So just like you can notice, we have the incident ray, we have the refracted ray, we have normal, we have air right over here at the top, we have glass at the bottom, and right over here we have two other angles which are very important to notice. So this one, the angle number 1, is the angle of incident, which is between the incident ray and the normal. Right over here we have angle number 2, and this one will be the angle of refraction, which is going to be in between the normal and the refracted ray. Just to have a better idea of what this diagram represents, let's remember one more time the experiment of the pencil, and of course the different images that we were getting from there. So, right there in your experiment, you had two mediums. You had air, and you had glass and water right here at the bottom. So, first of all, we were getting some incident rays, which were the light rays that were coming from the air. And right over here, it was getting in contact with glass and water. Something very important to notice is that we have the normal line. What is the normal? So basically the normal line is a line that is perpendicular to the, let's say, to the middle of the mediums. Of course, where the incident ray is in contact with both of them. Alright, so, and continuing like this, like, if we will continue with the same path of the incident ray, you will notice that it will continue its way in this dotted line. But remember that the index of refraction of air and the index of refraction of glass is different, which means that when the incident rays enter their way right over here inside glass or water, their path is going to be modified. So, basically, this is what explains why we were seeing a distortioned image in our experiment. So right over here, this part at the top will be like the image that we will perceive of the half of the pencil that is out of the glass and out of the water. And the image that we will perceive right over here, below the glass and the water, will be the image that is distortioned, which will be like bigger or that doesn't really seem to match with the other half of the pencil that is at the top. And it's very applicable, the Snell's law, in our daily lives, specifically when we see different substances or different objects through different mediums. Alright, so let's continue. Now we're going to take a look at the formula and the concepts that are, of course, part of the Snell's law. The Snell's law equation that relates the variables is n1 sin of the angle 1 equals n2 and sin of the angle 2. Remember, n is the index of refraction. So n1 represents the index of refraction of the first medium. Sin, angle 1, represents the sine of the angle of incident. Check to be sure that your calculator is in degree mode. So let's say that the standard mode of calculators is a degree mode. So as long as your calculator is being set like normally, it is going to be in degree modes. Just in case you're not sure, you can just reset your calculator, so it will go back to the degrees mode. Okay. And now we go with n2 represents the index of refraction of the second medium, and sin of the second angle represents the sine of the angle of refraction. The formula is very simple. You can just notice that n1 is multiplying sin of the angle 1, and the index of refraction 2 is multiplying sin of the angle 2. It is necessary to remember this because we're going to be rearranging the formula later on. For example, if we want to find the index of refraction of our second medium, then it will be pretty simple. We can just move the sine of the second angle, that is multiplying the index of refraction to the left side of the formula, right? So then we will get our formula to find the index of refraction of the second one. And what happens if we want to find the sine, or most likely, what happens if we want to find the first angle? Then we're just going to move this to the other side of the formula. So just for you to take into account, now we're going to go with some application problems, so you can actually notice the way we are going to apply the formulas and all the theory that we have been learning so far. So we have problem number 1 right now. It says light at an angle of incidence of 44 degrees moves from air to a liquid. The observed angle of refraction is 31.4 degrees. What is the index of refraction of the liquid? Identify the liquid. Be sure that your calculator is in degree mode. What is the angle of reflection? Alright, so just like always, remember to write down the givens that you have from the problem. So we have the index of refraction of the first medium. So just like I was saying, it comes from air, and we know that in air the index of refraction for light is 1.0. Then what is the first angle? The first angle is 44 degrees. What is the second angle? The second angle is 31.4 degrees. And of course, what they are requesting right now is the second index of refraction. So we are going to rearrange a little bit the formula, just like I mentioned. We are going to move the second angle, the sine of the second angle, to the other side of the formula. And the resulting formula will be this one. The index of refraction of the second medium will equal 1 times the sine of 44 divided by the sine of 31.4. So what is our result? The index of refraction of the liquid is 1.33. And also they were asking us about identify the liquid. So what is the liquid that has the index of refraction of 1.33? That is why you need to copy the table of content in your notebook. So now you can go back to the table of content and identify what liquid it is. I'm going to help you out a little bit here, and the one that has 1.33 is water. Alright, but just in case you receive another index of refraction, you can go back to your table of content and double check it in there. And what is the angle of reflection? This is something very important. Remember that we have reflection and refraction. So when we talk about the index of refraction is the one that is under the liquid. But reflection, let's say that is the one that is above the liquid, which is in air still. So which one was the angle of incidence? It will be 44 degrees. Alright, let's continue. Now we have problem number 2. This one is a little bit simpler, but it might be a little bit trickier, so it is always important that you take it into account as well. It says, light passes from air into water. If the angle of incidence at which the air strikes the water is 40 degrees, what is the angle of refraction? So let's check our givens. We have both the index of refraction of air and water, 1 and 1.33, and we have the angle of incidence, which will be 40 degrees. So here is where it starts getting a little bit tricky. So right now, what I did here right now was that I moved the second index of refraction from one side to another. So this will be the resulting formula that we have. It will be 1 times the sine of 40 divided by 1.33. So the result of this will be 0.4833. Okay. But now, here is something very important to notice. So we still have sine of the second angle, right? So we need to change this of position. But when we change the sine from one side to another, notice that it is going to become the negative or the inverse sine of the angle. So Basically, when we move the sin from here to there, we need to type down in our calculators the sin elevated to the minus first power of the resulting number that we have. So how are we going to type down the sin elevated to the minus first power in our calculators? Well, it is very simple. You just need to click on Shift and Sin in your calculator. So after you press Shift and Sin, you are going to notice that you will already get the symbol of what we are looking for right now. Then you just have to type down the resulting number, which will be 0.4833, and then you are going to get the result for our problem. So what is the result? The index of refraction is 28.9 degrees. It is very simple. You just need to follow these 3 very simple steps. Just write down the givens of your problem, and of course, rearrange the formula a little bit to get the information that you're looking for. And lastly, operate step by step so you don't get confused. And ta-da, you will get the results. I know it was a little bit of a long topic to explain, but just like always, those topics are very simple as long as you know the basic theory and you have all of the formulas, units, and everything in order. So thank you a lot, guys, for coming to today's lesson. I really appreciate a lot the work that you're doing to continue learning and, of course, to continue being part of all of the lessons and activities that we have for you. So I wish you the best of luck. Remember that you need to go back to the activities section that I showed you in the first part of the video so you can double check the activities that you need to finish today. With that being said, guys, I wish you the best of luck one more time, and take care, please. I will be seeing you around during the mid-session and, of course, next week. Goodbye, guys.